Okay, we're going to start lesson 102 today. You should have your whiteboards. I think I really like this lesson because I think it's going to be a really good reminder, a really good review of our decimal numbers and our fractions and how those correlate together. And if you would turn your books to page, you should have your math textbooks. So if you don't have those, go get those. And then you can follow along with me. I was going to do the problem solving on 648, but I've changed my mind. I think we're just going to go right on into the lesson because I want you guys to get some practice with this. So if you look on page 649 on lesson 102, it has some examples there under the new concept right at the top of the page. And it says, we have used decimal numbers to name lengths that include a fraction of a centimeter. For instance, the length of this segment can be written as 23 millimeters or 2 3/10 centimeters. Okay, so look at those rulers. You see the millimeter up on the top, and then you have the centimeter down at the bottom. So there's two different ways they're saying that you can measure it. You can measure it in millimeters or you can measure it in centimeters. If you're measuring it in millimeters, those are whole. You can measure the whole thing as 23 millimeters. But if you're going to measure it in centimeters, look at the bottom ruler there. You have 2 centimeters, and then it isn't all the way to 3 centimeters. It's between 2 and 3 centimeters. And we know that if you divide a centimeter into 10 parts, that's a millimeter. So what it's done there between 1 and 2, 2 and 3, there's 10 divisions, and each of those represents a millimeter. Okay, if you look on down the page, go ahead and read with me. Likewise, on the following number line, the distance between every 2 whole numbers is divided into 10 equal parts. So the number line, what they're doing is trying to show you that a number line and a ruler are exactly the same thing. So I know a lot of times when you guys have problems, when it asks you, like it shows the arrow there on that number line, you get confused and you don't know what the number is. So just think of it as a ruler. And I think that's a really good comparison when we're talking about decimals and fractions, is because you're used to that on a ruler. If I ask you to measure a line, you'll tell me, oh, it's 2.5 inches or it's 3 3/4 inches. You're using decimals and fractions. You just may not be aware that that's what you're doing. So I think it's a really good comparison to compare the number line and the ruler. So if you look at this number line, it's basically the same thing as a ruler there. When it's pointing to the 3, between the 3 and 4, it's got the line divided into 10 pieces. Remember, we count the spaces because we want to count the pieces. So to count the pieces, you have to count the spaces. That's what you're always counting on a number line and on a ruler. You're counting the pieces. Okay, so it shows that it's 3 1/10. If you look at the answer there at the side of the number line, it shows you that as a mixed number, 3 1/10, where it has a whole number and a fraction together, what we call a mixed number. And it also has the decimal number, 3 1/10. Now, if I just say it out loud, 3 1/10, they sound exactly the same. But we write them differently as a fraction and as a decimal number. Okay, then it continues. If the distance between whole numbers on a number line is divided into 100 parts, what do you know that is divided into 100 parts? There's a couple of things that we've talked about in math class before throughout the year. A dollar is divided into 100 parts because it has 100 cents in a dollar. So it has 100 parts. A meter stick has 100 parts because there are 100 centimeters in a meter. Okay, let's continue. The points between the whole numbers may need to be written with 2 decimal places. The arrow below is pointing to 3 25 hundredths, which can be written as 3.25 or as a mixed number, 3 25 hundredths. Okay, so look at that example. It looks really strange, I know. It's got all of those tick marks on it. And that's why I don't want those number lines to throw you. I want to practice on that a little bit today. If you'll notice, there's the 3, which is a whole number, and then the 4, which is a whole number. Okay, now there's a whole lot of numbers in between, because in mathematics, we know whatever number we have, whatever two numbers we're talking about, there's always can be a number in the middle. And if we take this number and this number, there can be a number in the middle of that. And if we take this number and this number, there's a number that can be in the middle of that, and so forth. We can always put another number in between the numbers. Now, if that's, let's say I'm talking about 1 and 5. If I've got 1, 2, 3, 4, 5, I can put 2, 3, and 4 in the middle, right? Can I put a number between 1 and 2? Yeah, 1.5. Can I put a number between 1 and 1.5? Yeah, I can put 1 1/4. Can I put a number between 1 and 1 1/4? Yes, 1 1/8. I can continue as long, it's infinite how many numbers that I can put in there. And so that's something you need to remember on a number line. It's saying here you've got your whole number 3 and your whole number 4, and you've got that arrow. Where do you begin to figure out what that number is? Look at the number line, and you will see, just like on a ruler. Do you see the lines there? You've got lines that are a little bit longer than the other lines. And you've got 10 of them. There are 10 lines that are longer than all the other lines. So that's your first break. And if you'll notice, and you continue going down on those number lines, actually there's, let's see, 1, 2, 3, 4, 5, 6, 7, 8. There's 9 of them. It cuts between 3 and 4 into 10 pieces. And then those 10 pieces are cut into 10 pieces. And that's what your centimeters, millimeters are. Because it's centimeters between the 3. It's dividing that between 3 and 4. And then it's dividing the centimeters into millimeters. Okay? If you don't understand, I know it's confusing. It's very confusing. Bear with me. We're gonna keep thinking about this. And it says, if you inspect a meter stick, and you guys may or may not have a meter stick at home, you'll see that it's divided into 100 centimeters. So if you look up here, it would look like this. 1, 2, 3, 4, here's a centimeter, and it would go until 100, and that would be a meter. Because a meter, remember, 1 meter is 100 centimeters. Okay? Then, also, 1 meter is 1,000 millimeters, because if we take those centimeters, we know that 1 centimeter is 10 millimeters. Then we can just put those 10 millimeters, there's the half, and I know I'm going to put 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Here's 10 millimeters. And if there's 100 centimeters in a meter, and I have 10 millimeters in 1 centimeter, I would have 10, 20, 30, 40, 50, 60, 70, 80, on until I have 1,000 millimeters. Okay? I think all of you are very familiar with the meter stick, and you're good with that. You know there are 100 centimeters in a meter. There are 1,000 millimeters in a meter. If you're good with that, which I'm pretty sure most of you are, let's continue. You're going to get it, okay? Just remember that comparison. Let's look at example 1. Santiago is 162 centimeters tall. Okay, 162 centimeters tall. What is Santiago's height in meters? Okay, he's 162 centimeters. and we want to know what it is in meters. Well, how many centimeters does it take to make a meter? 100. Look, I have 100. So I know he's at least 1 meter. So he's 1 meter. Okay, now look in your book. What are we going to do with this part? Look in your book. Let's see. It says 100 centimeters equals a meter. So Santiago's height is 1 meter plus 62 centimeters. Since 62 centimeters is 62 hundredths of a meter, Santiago is 1 62 hundredths meters tall. So 162 centimeters equals 1 62 hundredths meters. Now, there were some problems like this on that benchmark test that you took yesterday, and most of you got the correct answer. Some of you did not, and you got a little bit confused about this, okay? So, if we're looking at this, let's say that we've got, I'm going to go ahead and draw these meters in. Here's half. Okay, so let's say that this is 60 centimeters, and then we've got 61, 62. Now, I don't know if that helps you have a visual of that or not. Let's do another example, see if it becomes clear to you. Example 2. Write the decimal number to which each arrow points. Okay, so for A, the first thing we have to do is, it has a whole number, so what whole numbers is the arrow pointing in between? And it's pointing in between 9 and 10. So we know the whole number part. We know the whole number part. So we know it's going to be 9. It's not 10 because it's not as big as 10. It's less than 10, but bigger than 9. So we know 9 is going to be the whole number. And then how many parts is it divided into? Between 9 and 10, how many parts are there? How many do we have? Well, it looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 parts total. So we know how many we have goes on the bottom. It's the denominator. The numerator is how many do we want? Well, we want from 9 to that arrow. So how many is that? 1, 2, 3, 4, 5, 6 spaces. So our answer for A is 9 6/10. Now, can you write that as a decimal? 9 6/10. That first place value is tenths. Now, some of you missed that on the benchmark test when it asked which number was in the hundredths place. And I'm going to review that with you here in just a moment, but I want to go ahead and stay on this track right now. Okay, so 9 6/10 is the A part. Let's look at the B part. What number is it? Well, okay, this is a little trickier, all right? It's between 7 5/10 and 7 6/10, all right? So what do we know it's going to be? At least. It's going to be at least 7 5/10, because 7 6/10 would be too much. It's just like we did with the 9 and the 10. So we know it's going to start with 7 5/10, but it breaks it down even farther to where how many pieces is between 7 5/10 and 7 6/10. There's 10 pieces. Okay, so how many pieces do we need? It counts over 1, 2 spaces if you count that over. So it's 7 52 hundredths. as a decimal. Now, I know that this is a really hard concept. Guys, this is just something extra that we're doing together this week. All of these problems this week is just something extra. You're going to really delve into this a lot more next year. So I just want you guys to see it, to hear it, and so that when you start really working with percentages, fractions, and decimals, particularly, you'll really get heavy into it in 5th grade. You will have heard it, okay? So if you kind of get what we're doing, great. If you're just really confused, it's okay. It's all right, okay? I just want you to have the experience of seeing it. And if you think, I think I know what you're talking about, great, okay? All right, so take the pressure off yourself, but allow your mind to try to experience something new, okay? Don't just say, oh, I don't understand this, I don't get it. Don't do that, because you don't get it yet, okay? So you just have to hear. I mean, think about when you were learning to talk. You said mama, dada for months before you said anything else. So it just takes, you have to start somewhere, guys. You have to start somewhere. And that's what I'm trying to get with you with some of this information that we're going to go over this week. It's your first try at it, okay? And so as long as you can, this is important. 1 meter is 100 centimeters. 1 meter is 1,000 millimeters. And I think all of you know that. That's where you should be, okay? And we're taking that concept and we're going, okay, if you know that, then you know that there's 10 millimeters in a centimeter, and you can continue and really get into some heavy duty counting, okay? All right. If you look at example 3, let's go to example 3. Round 9 6/10 to the nearest whole number. So what you have to do is you have to think, okay, here's a number line, and I've got 9 and I've got 10. Okay, 9 and 10, and it says it wants you to round 9 6/10. So I need to divide this line into 10 lines because 9 6/10, there's 10 parts. So 1, 2, 3, 4, 1, 2, 3, 4. So if we go 9 and 1, 2, 3, 4, 5, 6 is right here. Is it closer to 9 or 10? I'm rounding to the nearest whole number. It would be closer to 10. So I would round that to 10. Okay? Let's round 7 52/100 to the nearest 10th. Okay, this is getting a little harder. Erase this. So I've got my number line here, and I've got 7, and it's going to be between 7 and 8, and it's 52, so 5/10. So I'm going to divide this line into tenths, because if I leave off the 2, I'm just going to do 7 and 5/10 first, okay? So 1, 2, 3, 4, 1, 2, 3, 4. So I've got 7 and 5/10. 1, 2, 3, 4, 5. So I'm right there. So that's right halfway between. Now let's do my 200ths. So that means each of these in between here are going to be divided into tenths. So 1, 2, it's going to be right here. So is it closer to 7 or 8? It's going to be closer to 8. Okay? All right. Oh, but wait. I read that wrong. And that's what some of you guys did on your benchmark test. But look what I did. I checked my work. I thought, does that work? No, I'm supposed to round it to the nearest tenth. So this would be 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, and 10/10 would be 8. So is it closer to the 5/10 or the 6/10? It's closer to the 5/10. So that's what it would be. Well, we wouldn't do the hundredths because it wants to know the closest tenth. So 7 5/10 would be what we would round it to. Okay? All right. That's pretty heavy duty stuff for your brain today. I think what I would like you guys to do, instead of doing the problems, I want you guys to see what you can do with the lesson practice. So the lesson practice is A through K. Work that for me. And then tomorrow I'll go over the answers, or I can post those answers, but I also will go over those answers with you tomorrow, because just having heard it and worked through it, something might click. You never know. So do your best, see what you can come up with, and I will have math class tomorrow. See you then.